Assalamualaikum warahmatullahi wabarakatuh. My name is Zafatul Syahda binti Zarin. My metric number is CF210219. So I would like to present about shear force. Okay, shear force is a force acting in a direction which is parallel or tangential to a section of the body. Okay, shear stress. Shear stress is a stress acting perpendicular to the cross section of the load carrying member, while shear strain is the ratio of displacements to the body original shape and dimension due to the effect of shear stress. A beam will bend and undergo elastic deformation vertical when the vertical component of force acting perpendicular to the longitude axis of the beam. So when we're doing mechanics of materials laboratory, we can study the principle involved when determining the shear force in a beam. Second, to investigate the shear force variations when the point's load increase. Third, to investigate the shear force variation at the beam's cut position for various loading conditions. So when we're doing mechanics of materials for shear force, according to this lab experiment, the shear force increase as the weight applied to the beam increase, indicating that the load is directly proportional to the shear force. So when we compare, we doing calculation and we doing on lab, so the data is almost accurate. So what shear force can relate with civil engineering? Shear force is the external resistance created in a beam cross section in order to balance transverse external load in acting on a beam. Consider following beam. It does not matter from where you take a section. When you add force, act on it, it should be in equilibrium. Next, shear force is educated exactly for this purpose, to bring the sections to equilibrium in vertical direction. It acts parallel to cross section. So just by applying force balance in vertical direction on a free body diagram, we can determine value of shear force at a particular cross section. Usually some convention of the shear force in as follow. In a nutshell, now we can apply the same concept in different cross section and find out how shear force varies along length of the beam.
Assalamualaikum and very good morning to Dr. Abdullah Faisal. My name is Nur Iqbal Hafizul bin Abdullah. My metric number is CF 210354, and I'm from group 1. Will present about lab 2, which is bending moment. For the direction of bending is solid mechanic. In solid mechanic, a bending moment is the reaction induced in a structural element when an external force or moment is applied to the element, causing the element to bend. The most common or simplest structural element subject to bending moment is the beam. Next, for the relationship about bending and in real construction, in any structure we need to calculate bending moment, shear force, axial force, torsion, and the others for different members. For beams, we generally need to calculate bending moment and shear force acting on due to the applied forces. We need to know these quantities so that we can provide an appropriate size of beam or columns which is capable of resisting the applied force. That's all from me. Thank you.
Hi, my name is Nurin Zati. Today I will explain about the lab 3, which is deflection of beam. So deflection is the degree which a particular structural element can be displaced with the considerable amount of load, and the beam can be bent or moved away from its original position due to the forces and load that we apply. So deflection, also known as displacement, which is it can occur from internally applied load or from the weight of the structure itself. So in the lab activity, in the laboratory, we are using aluminium material as a beam and apply a load onto the beam according to the cases. We have 3 cases, which is the first case with load 5 gram, 50 gram, case number 2 is 100 gram, and case number 3 is 150 gram. With that way, we can measure the deflection beam of our group based on the cases that we have. So, in real construction, deflection is important to measuring the weight of the structure and how it affect the surrounding beams. And a beam is necessary to ensure the structure of building's floor, and when it's too much movement, it can affect the overall structural integrity of the building. So deflection or displacement is very important in real construction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atika binti Yaakob. My metric number CF210027. Okay, for buckling of compression member, buckling is characterized by the sudden sideways failure of a structure member that is subject to high compressive stress, where the compressive stress at the point of failure is less than the ultimate compressive stress that the material is able to bear. Mathematically, buckling is instability that lead to a failure mode. Compression member are commonly used as column in building structure, cord or web in trusses, or brace in frame structure. The maximum strength of a steel compression member depends to a large extent on the member length and support condition. Steel compression member are commonly classified as short, intermediate, or long member. Each range has its own characteristic type of behavior. For example, local buckling is the major concern for short compression member, while overall buckling affect the strength of long member. Intermediate member are more complex to analyze, but also are the most common in steel structure. They may fail by a combination of yielding, overall buckling, including interaction between buckling modes.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Adina Surya binti Muhammad Nasir, and my metric number is CF210275. Okay, in this lab 5, we were going to do the tensile test, which is the function of tensile test is a destructive test process that provide the information about the tensile test strength, yield strength, and ductility of the metallic material. It measures the force required to break a composite or plastic specimen and the extent to which the specimen stretched or elongated to that breaking point. This tensile test, we were using a UTM machine to collect the data and the result. Beside that, in this tensile test, we are using a reinforcement bar, which is size of sample is 16 mm. After finish the test, we will get the result to assure that simple or that material can use or not. The result of the lab, laboratory and experiment exercise was not same because of the technique and the error of disability of human. In the experiment exercise, we will get the yield strength is 559, ultimate strength is 713, and the yield size, the yield strength and the ultimate strength value are higher than the accepted code of practice. When compared to mill steel, the aluminium reinforcement bar has a higher ductility rate, which is that and used to determine whether the steel reinforcement bar strength Face Standard Code of Practice. So as we know, we perform tensile test is to know how a material will behave in certain condition or under certain threshold. The result of a tensile test help engineer decide how and when to use a material when they are design a project. So that's mean that tensile testing help guarantee the safety of a material. That's all for me. Thank you.